Every piece of twisted wreckage tells a story if you know how to read the physics. To the untrained eye, a crash site is a scene of senseless chaos, a graveyard of charred metal and shattered lives. But to a forensic engineer, this debris is a witness. It is a data-rich document written in the language of tensile strength, thermal gradients, and shear force. By synchronizing 3D simulations with actual debris patterns, we've mapped the thermal expansion that sheared metal like paper. This isn't just a recreation. It's a forensic autopsy that transforms chaotic fire into cold, undeniable structural proof. For decades, the explosion of Flight 143 has been a breeding ground for wild conspiracy theories and unanswered questions. Skeptics looked at the suddenness of the catastrophe and saw shadows of external interference, missiles, ordnance, or sabotage. But shadows vanish when you turn on the lights of 2026 grade computational analysis. We are freezing time at the exact millisecond of ignition, using advanced fluid dynamics to reconstruct the blast from the inside out, proving once and for all what really tore this fuselage apart. The heart of the mystery lies in the center wing tank. Using 2026 grade computational fluid dynamics, we can now visualize the volatile fuel-air vapor mixture within that dark, sealed vault. On the day of the accident, the aircraft had been sitting on the tarmac for 3 hours in 32°C heat. The air conditioning units, located directly beneath the tank, had been running continuously, radiating immense heat upward. As the temperature inside the tank climbed to 53°C, the fuel reached its flash point. We tracked the thermal energy climb to the exact millisecond an electrical spark bypassed aged insulation to trigger ignition. This was the baseline of internal pressure growth that contradicts the external force theories often cited by skeptics. As ignition occurs, the simulation reveals the supersonic expansion of hot gases as they collide with the internal structural ribs of the aircraft. We can now demonstrate how the specific wave pattern of the blast created the unique star-shaped fractures found in the recovered wreckage, a signature that only an internal explosion can leave. By correlating digital stress test data with high-resolution scans of the physical debris, we proved the explosion originated from within. The structural failure sequence is a brutal breakdown of physics. We watch the millisecond by millisecond progression as internal pressure exceeds the tensile strength of the fuselage skin. This illustrates the zipper effect, where the rapid peeling of the aluminum shell mirrors exactly how the aircraft broke apart mid-air. Identifying the specific failure of the longitudinal beams finally explains the flight path recorded just before the total hull loss. It wasn't a controlled flight, but a violent aerodynamic reaction to a catastrophic loss of weight at the nose. This 3D reconstruction does more than solve a mystery. It solidifies the implementation of nitrogen-inerting systems in modern commercial aviation. The synthesis of digital physics and physical wreckage provides a final, indisputable closure for the historical record. We have evolved beyond the chaos of tragedy into the clear reality of physics. We no longer have to guess what happened in the dark. We have the light of the data.